Hello, Bee here, and welcome back to Integrated Physics and Chemistry. Have you ever added food coloring to water and noticed that as you add more food coloring, the color gets darker? That is because you are increasing the concentration of food coloring with every drop. The amount of water remains constant, but there is more food coloring with each drop you add. In chemistry, we use the term molarity to describe the concentration of a solute in any given amount of a solvent. Before we get started, let's look at our goals for this lesson. By the end, you'll be able to define concentration, molar mass, and molarity. Calculate the molar mass of a substance. Calculate the molarity of a solution. If you remember back to one of our first lessons on the metric system, we talked about the unit mole. No, not that mole! In chemistry, a mole is the measure of the amount of a substance. In that lesson, we discussed how a mole is just a physical count of something, like a dozen is 12 or a pair is 2, except a mole is very large. I was recently looking at a recipe and noticed that a dozen eggs had a mass of 850 grams, but I needed 2 dozen eggs. What would the mass be for 2 dozen eggs? 1,700 grams. What if I had a half dozen eggs? It would have a mass of 425 grams. This same approach to mass calculations works for moles too. If 1 mole of sodium chloride has a mass of 58.44 grams, then what would be the mass of 2 moles? 2 moles of sodium chloride would have a mass of 116.88 grams. What if I had 1/10 of a mole of sodium chloride? What would be the mass? It would be 5.844 grams. The mass of 1 mole of a substance is called its molar mass, and you can calculate the mass of any compound using the periodic table. To calculate a compound's molar mass, you find how many atoms of each element are present in the compound, then multiply that number by the atomic mass of the element from the periodic table. Finally, you add it all up for the total molar mass of the compound. Let's work through a few examples together. Let's start with sodium chloride. How did I know that the molar mass of sodium chloride is 58.44 grams? Using the periodic table, I was able to determine that the atomic mass of sodium is 22.99 AMU, and the atomic mass of chlorine is 35.45 AMU. I have 1 atom of each element, so I multiply each element's atomic mass by 1, and then add the numbers together for a total of 58.44 grams. The difference between molar mass and atomic mass can sometimes be a little confusing. Molar mass is the mass of 1 mole of a compound, while the atomic mass is the average mass of 1 mole of an element measured in grams and can be found on the periodic table. Let's try another one. What is the molar mass of calcium fluoride, CaF2? First, I find the molar mass of calcium, 40.078, and multiply it by 1 because I have 1 atom of calcium. Next, I find the molar mass of fluorine, 18.998, and multiply it by 2 because I have 2 atoms of fluorine. That gives me 37.996. Now, I add together the mass of the calcium atom and the mass of the fluorine atoms for a total sum of 78.074 grams. So, the molar mass of calcium fluoride is 78.074 grams. The correct way to say this is that the molar mass of calcium fluoride is 78.074 grams per mole, which means that 1 mole of calcium fluoride has a mass of 78.074 grams. Why don't you try one on your own? What is the molar mass of lithium sulfide, Li2S? Pause the video and give it a try. Welcome back! Let's see how you did. We have 2 atoms of lithium, so we multiply lithium's atomic mass of 6.94 by 2 and get 13.88. We have 1 atom of sulfur, so we multiply sulfur's atomic mass of 32.065 by 1 to get 32.065. Now, we add those numbers together for a total of 45.945 grams per mole. There are a few different ways to measure the concentration of a solution. But the most common way, and the one we will be using, is called molarity. Molarity is defined as the number of moles of solute per liter of solvent, or moles per liter. The higher the molarity, the higher the concentration of the solution. Similar to density, the units for molarity are very important. Let's practice calculating the molarity or concentration of various solutions. What is the molarity of a solution that contains 0.50 mole of lithium chloride dissolved in 1.25 liters of water? Let's use the same method we used for our density problems, and start with a list of our variables. Our formula for molarity is m equals moles divided by liters. So for our list, we need an m, moles, and liters. M is our unknown, so we can place an x next to m. For moles, we have 0.5 mole of LiCl. And for liters, we have 1.25 liters. Check our units. Are they correct? Yes, they are. Okay, now let's fill our known values into our formula and calculate m. We get m equals 0.5 divided by 1.25, giving us a molarity of 0.4 mole per liter. How about we try another one? What is the molarity of a solution that contains 63 grams of sodium chloride dissolved in 0.65 liter of water? Let's start with our list. M is our unknown, so that gets our X. We have 0.65 liter, so that goes with the L. This leaves us with 63 grams. While we don't have moles, we have grams, and that gives us enough information to find moles. Earlier in this lesson, we calculated the molar mass of NaCl to be 58.44 grams per mole. To find the number of moles, we can use the conversion factor. Moles equals grams divided by molar mass. In this case, moles equals 63 divided by 58.44, giving us 1.078 moles. We add that to our list. Now we are all set with our units and can solve for the molarity. M equals moles divided by liters, so X equals 1.078 divided by 0.65, giving us a concentration of 1.66 moles per liter. Okay, one more. That's it, I promise. What is the concentration of a solution made by dissolving 70 grams of calcium fluoride in 250 milliliters of water? Let's start with our list. M is our unknown, so it gets an X. We put the volume, or 250 milliliters, next to the L. And finally, we place the number of grams, 70, next to the moles. How are our units? Oh no! Neither of them are correct. Okay, let's fix them. Why don't we start with our moles? We have already calculated the molar mass of CaF2 as 78.074 grams per mole. Using the conversion formula, the number of moles is equal to the mass divided by the molar mass, or 70 divided by 78.075. This gives us 0.897 mole of calcium fluoride. Now, let's convert our milliliters to liters. Do you remember how to do that? Back in Unit 1, we learned our conversion factor that 1 liter is equal to 1,000 milliliters. For metric conversions, we write our given, in this case 250 milliliters, then multiply it by the conversion factor made into a fraction. We want our given unit in the denominator and what we are solving for in the numerator. Just a reminder, this works because when there are equal values in the numerator and the denominator, it is the same as multiplying by 1. So we have 250 times 1, or 250, and that is divided by 1,000. So 250 milliliters equals 0.250 liters. Let's add that to our list. Finally, our units are correct and we can solve for molarity. X equals 0.897 divided by 0.250, giving us a concentration of 3.588 moles per liter. You may be asking, why would we need to worry about a problem like the last one, where we have grams and milliliters, and we aren't just given moles and liters? Well, in a lab, when you use a balance, it usually measures in grams, so it is rare that you would know the moles without calculating it from the number of grams. Likewise, often in a lab environment, we use milliliters because a liter is too large to measure accurately. That's why practicing problems like our last example are important. You will have more practice with these types of examples in the lesson PDF. As we went through the lesson today, we defined concentration and learned how to calculate the molarity of a solution. We learned that the more concentrated a solution is, the higher its molarity, like in our food coloring example in the opening. We also learned how to determine the number of moles of a compound when given the number of grams of a sample and reviewed our metric conversions. Until next time, remember, the universe is vast and full of surprises, so never stop exploring. I'll see you next time. Hey, hey.